Welcome to the Shatterbox video guide. In this video, I will walk you through the installation and usage of the library, but also map optimization strategies so that anyone can have optimized voxel destruction in their Roblox games. If you're here, you already know what Shatterbox is, so I'm just going to get right into the tutorial. Starting with a new experience, the first thing you're going to want to do is put Shatterbox into replicated storage. Oops. You could see my OBS tab open there for a second. So you put Shatterbox into replicated storage, and if you're only using Roblox Studio and not Blink or Rojo, this is the complete installation. The only other thing to keep in mind is to require Shatterbox on server initialization. This is so that Blink can be properly initialized. If a client joins before the server initializes Blink, they'll get an infinite yield warning. So yeah, you don't want that. Just require Shatterbox on server initialization like this. Yeah, I'm kind of slow at typing. But you just require the main module like this, and since it's, first line of server script, it's going to be required on server initialization, and you'll be all good to go. In any other script, you can require Shatterbox anywhere, and you should be able to use the library as intended. And you don't have to do anything on the client side. It will do it automatically. Now I'm going to show you the setup for Rojo, and then if you're an existing Blink user, I'll show you the setup for that as well. You can skip forward, I'll put time cards in the description, so the video should be segmented. Alright, so the installation for Rojo users. After you've downloaded your Shatterbox zip file, you're just going to want to extract it, and then place this entire package into replicated storage. In my case, this is going to be shared. And you might also want to rename Shatterbox 7.7 or whatever the version you're using is to just Shatterbox. This way you can use it in a consistent way, and when you go to update it, you won't have to change that version number. Now, this should be the complete installation for Rojo users. You still have to keep in mind to require Shatterbox on server initialization at some point. Just in some script, when the server starts, require Shatterbox. That should be it. Now, if you're an existing Blink user, I will show you how to do that using both Roblox Studio and Rojo. Blink users using Roblox Studio, the setup is a little more complicated. First, you have to go over to GitHub or wherever the Rojo installation is for your current version, and then in the Shatterbox Blink file, you want to copy its contents. Like that. And then, in your Blink editor, you can save this as Shatterbox. Like that. And then in your personal Blink file, all you want to do is import Shatterbox. Like that. And then you can save it. After you regenerate your Blink files, like that, going to want to redefine the path variables in the main module. So open up Shatterbox, go into the main module, and then the path to client and path to server variables, you just want to redefine those to be your client and server Blink files. Thought I had it copied. There we go. So after you've done that, that is the setup for Blink, and you can continue to use the library. For Blink users using Rojo, the first thing you're going to want to do is import the Shatterbox Blink config to the top of your personal Blink config like this. Just import the file, and then regenerate your Blink config. Now, the only other thing you need to do is to redefine the path to client and path to server variables in the main module to be your personal Blink files, like this. So just set the path variables, and then you should be good to go. Now, whenever you update Shatterbox in the future, what you'll have to do is just update, regenerate your Blink config after you put Shatterbox in the same spot it was, and then redefine these variables. That's it. So now that you followed the relevant installation instructions, you can finally start trying to perform voxel destruction. So I've imported this building that has GridSize 4 walls and GridSize 2 windows. I have set that via this number attribute named GridSize, which is the preferred way to set the grid size of parts in the library. You can also do it in the destruction function, which I'm going to show you now. I'm going to start with a physical hitbox. So one that is a part in the workspace, and it just performs voxel destruction around it. So I'm going to make it transparent, anchor it, and one thing to keep in mind is that non-divisible parts will be interacted with by Shatterbox by default. They'll fall down, and that's a setting that you can change. So for now, I'm just going to give this the indestructible tag so that this part doesn't fall down. And then in this server script that's already here, I'm going to connect to the heartbeat. And whenever the heartbeat happens, I'm going to pass in the part that I just made to the destruction function. So this doesn't tell Shatterbox to destroy the part. It tells Shatterbox to use the part's C-frame, size, and shape as the hitbox of voxel destruction. And there's not going to be any debris. So let's see how that works. All right, nice. So you can see we've got voxel destruction going. Now, what if you wanted to not use a physical hitbox? What if you wanted to just pass in a C-frame, size, and shape to perform voxel destruction? That is also something that you can do. And you do that by creating your own hitbox. And I'll show you a brief example where every time a player joins the game, a hitbox spawns around them and just starts performing voxel destruction. Okay, so what does the library consider a hitbox? A hitbox is a Lua table, and it has to have a C-frame, a size. Actually, that's it. Just a C-frame and a size. If you don't provide a shape, the shape will default to ball, but you can provide a shape like this. enum.partType, cylinder, corner wedge, whatever. And if you choose to do this, you can also put any of the destruction parameters in here, and I'll explain to you what destruction parameters are later in the video. Okay, so there's actually a better way provided by the library to create hitboxes. Create hitbox is an object-oriented function, and it's nice because it gives you access to all of the destruction functions and some helper functions. Start creates that connection for you, so you don't have to write connections all over the place. Weld2 makes the hitbox follow a base part, and if that base part gets destroyed, the hitbox is automatically stopped, so it's kind of nice. Destroy hitbox is the same as calling stop and then unweld. It doesn't actually remove any of the data from the hitbox. Okay, so what do we want to do? We want to connect to the character added of the player. And we want to weld the hitbox to their humanoid root part. And then we can start the hitbox. And now, when character is removed, we just want to stop the hitbox. Because, and I did just say that the hitbox is automatically stopped when a welded part is destroyed, but if you go into workspace and the player character destroy behavior, if this is disabled, then the hitbox is not going to automatically stop when the character dies and respawns. You might think it's a bug. Okay, so we stop the hitbox, or let's call it destroy hitbox. And this should be good. We can just play the game and have voxel destruction around the character whenever they spawn in, right? So let's try that out. And I already made the base plate indestructible. Am I forgetting something? Oh, right, the hitbox is really small. Okay, so that was a mistake. We gotta give the hitbox some size. Oops, not that much. There, 10. Okay, so now you can see we're performing voxel destruction around the player character, and I'm not going to show you the respawning part because I have something cooler to show you right now. So the spawn location, it's got a decal. If you saw how it just disappeared just then, what if you wanted to cut it apart, as in like, cut apart the image? Shatterbox actually supports that with textures. So if you use a texture and map it the same way as the decal, like this, and then delete the decal, texture has to go on top, right? Now watch what happens. See? So that's kind of nice. If you've got any decals in your game that you want to divide, just consider replacing them with textures. Okay, so that's what I wanted to show you there. And this is it for the physical hitbox and the virtual hitbox. So now I would want to show you what if you want to make debris. Well, Shatterbox handles debris through destruction effects. You can define them in these folders, or these modules, but it's not necessary for you to define them there. These are where the default effects are defined, so if you want to like look at these and use them as examples, you can. This is a recreation of the Jujutsu Shenanigans M1s, where the floor voxels turn into bumpy floors and the walls become interpolated voxels. And on the client side, we just have one that creates rough edges around destruction. Okay, so what if you don't want to use those? You can define an onVoxel destruct effect like this. Shatterbox, register onVoxel destruct. You gotta give it a name. And then the parameters are voxel info. Okay, so what is an onVoxel destruct effect? An onVoxel destruct effect is this function callback, and it will be ran for every single voxel in the destruction. So you've got one voxel that you are acting on within this function. Info gives you information such as the state the hitbox was in when the destruction started. User data is user supplied information that you supply before the destruction to use in this effect. Is already debris is true if voxel was debris already and was not caused to be debris by this destruction. Dirty group ID is a little more complicated, and I'll explain what a dirty group is later. Is edge is true if the voxel lies along the edge of the destruction. So you've got any of that information to use inside of the onVoxel destruct effect. And something good to keep in mind is if you're not using an onVoxel destruct effect, the voxels aren't created and then destroyed. They just aren't created in the first place. So don't do this. And just leave the effect as this. So this is an effect which creates a bunch of voxels and then just immediately destroys every single one of them. It's better just to not use a onVoxel destruct if that's what you're going to do. Okay, so what are we going to do here? We're going to unanchor the voxels. Voxel anchored equals false. Okay, so this is our nice starting destruction effect. It's a server-sided destruction effect because we're registering it from the server side. Same thing with the client side. If you wanted to register a client-side effect like this, you would have to register it from the client side. And it is possible to have the one effect do different things on the server and client side. You name them the same thing. Okay. So now we're just going to create another hitbox, give it some size. We're going to use the part that's already in the workspace. All right, and now we set the hitbox's onVoxel destruct effect to the name of the one that we just created. Okay, and now we'll weld the hitbox to the part, and then start the hitbox. And now what we should see when we play the game is that, okay, taking a while to load, this part, when we drag it into the building now, it should cause the voxels to spawn and become physics debris. And they are. So this is nice, and you can see quite a bit of lag from all of those physics items. Okay, so that's a very simple onVoxel destruct effect. Now, I'm going to show you the on-voxel destruct effects that are already provided in the library. Okay, bumpy floor break walls. And this is going to transition into a brief explanation of the client-server algorithm. Okay, so bumpy floor break walls. What it does is it turns voxels that it considers to be wall voxels into interpolated debris. And anything that it considers to be a floor, you can see that it just gets displaced. I mean, it's hard to see underneath all of that debris, but you can see the floor voxels are getting displaced and not unanchored, while everything else is, getting displaced. And now, why are those ones stuck still? Because these are interpolated voxels, and they have automatic anchoring. I'll explain the puppeteering system later. But for now, we've just got, bumpy floor break walls. And now I'll show you the second effect that's provided in the library right now. Rough is an effect that can only be seen on the client side. And I'll explain why it can only be seen on the client side, even though we're starting it on the server side in a second. I'll just show you what it does. So on the server side, this effect doesn't exist. So the server just does not create voxels at all. It doesn't destroy voxels, it just never creates them. So you're left with a hole in the wall. But if I switch to the client side, you can see that this effect has rough edges like it should. So Shatterbox, when you're using the client-server algorithm, there are two instances of Shatterbox running at all times. There's one on the server side and one on the client side. What this means that you'll notice the most is that Shatterbox is not going to run as well in Studio as it will in-game, because your local device is going to be having to run two instances of Shatterbox at the same time. Okay. So what the client-server algorithm does is it reduces the part flashing caused by having workspace.streaming enabled set to true. So when I was showing you the destructions that were following the player character, you might have noticed that the building wasn't flashing, even though streaming enabled is set to true, because this is a new place, right? The client-server algorithm, what it does is when the server performs voxel destruction, it directly tells the clients the information of the original parts that were destroyed. That were destroyed. And then the clients create them and perform voxel destruction on them themselves, which is how you can have client-sided effects and server-sided effects without any communication of voxel information. It's just the original parts that get sent, along with the on-voxel destruct effect name and, the destruction information, like the parameters and stuff. Okay, I think that's all you really need to know about client-server for now. I mean, I guess it is also worth mentioning that client-server messes with the hierarchy of the map. So you can see that these are the parts that the client now owns. And on the server side, those same parts are in the camera. Oops. So if you have any code like raycasts or overlap parameter checks that rely on hierarchy, like you were doing workspace.folder, you're going to want to use tagging instead, because these parts will inherit all of the tags that they had before. So if they had like a tag like map parts, then they would still have that tag. And what you can do when doing that is when you're building something, or if your map parts are all in one folder, you can just go ahead and tag this folder map parts or whatever. And then when you go and destroy it, all of those changed parts will inherit that tag. So you can see that all of these are now map parts. And it's like that on the client side as well. Okay, so the next function I'm going to cover is the second destruction function. There are two in the library. There's ImaginaryVoxels and there's destroy. The difference between them is, well, the main difference is that ImaginaryVoxels does not have a frame limit. So you might experience freezing if you have, you might experience freezing in cases where you normally wouldn't with destroy, because this just is not frame limited. It'll all happen in one frame. And it passes you imaginary voxels and the existing debris that it cuts into. So I'm just gonna set up a run service loop just like in the beginning of the tutorial. Okay, so if we just pass in the workspace.part like we did before, we will be cutting into terrain and they will be passing imaginary voxels and the existing debris back to us. But that's just going to look like what I showed you originally. I mean, maybe it might be slightly faster, but I'm just going to show you how to utilize the imaginary voxels. Shatterbox provides you a function to instantiate these voxels without having to do anything yourself. And this will put it in the workspace, and it will give it a debris tag, unless you pass in a second parameter. If you pass in true, it won't give it the debris tag. And sometimes you don't want to have these voxels you're creating be debris right off the bat. In the case where you're using Shatterbox on voxel destruct, this is the way that you use on voxel destruct effects if you're using imaginary. So you pass in the name, whatever the name is, and then you pass in the voxel. And you also have to pass in the info parameters, the ones that you're going to need. And since you're the one who's calling the effect, you actually know which ones you need. Like, when you call this effect, it's not going to use info in any sort of meaningful way. It's just going to pass it straight to the unvoxel destruct effect. So you only have to define the information that you need in the info array. All right. Okay, you don't have to use the onVoxel destruct effect. You can just do whatever you want on these voxels. Like unanchor them, make some physics debris. Now, why would you use this over destroy? Well, for one, there's a lack of a frame limit. That could be a good thing for you, could be a bad thing for you. Bad thing, it could cause freezing in cases where destroy wouldn't cause freezing. But one of the major benefits is that you have the liberty to not create these imaginary voxels. So what the destroy function does is if you pass in an onVoxel destruct effect, it will just create all of the voxels it runs into and then pass them in. And then it's up to you to destroy them. It would be nice if we just didn't create those voxels in the first place if we didn't need them. And to do that, you would just continue in this loop, like with an if statement, not just like that. But yeah, the idea is instead of creating the voxel, you use the imaginary voxels information and optionally create it. So you don't just have to create and then immediately destroy things. And I guess I haven't explained this super well, but imaginary voxels is the algorithm that is used under the hood. So even when you're using destroy, imaginary voxels is used. You're just interacting with them in a different way. And, with destroy, it has a frame limiter. Right, so they can do everything that one another can, except for this, where you skip voxels and don't create them. All right, is there anything else I want to explain? I guess I should say that these are called imaginary voxels because they were never created in the first place. It's not like my library created them, destroyed them, and then is passing you this information. They just were never created. That's how imaginary works. It takes the original static map parts that it runs into with get parts and part, and it uses, from then on, just straight up math under the hood to get the final created voxels and the final created map parts. And these final created voxels arrays is this array that you're seeing. Okay. Yeah, I went on a little tirade there, but I'm just going to show you that this works, and then I will move on to the next function I'm going to explain. Might want to make that smaller. All right, so you can see that works. Not super sure why these are floating like that. They're anchored for some reason. Why are they anchored? Oh, because I didn't add the debris tag to them, so they got recreated. Yeah, so don't add the true if you want them to have the debris tag. If they don't have the debris tag, they're going to be considered for voxel destruction again. And what just happened is the debris got pushed out of the way, but it also had voxel destruction performed on it. So they just got re-anchored. And I'm not entirely sure why there's part flashing there. I think that's a bug, but I'll have to look into that. Okay, so now I'm going to show you the reset function and the reset area function. So I've set up a heartbeat connection, which just does destroy around the part that we were using before, and it has a cleanup delay set to 0. Now what that does is it makes it so that smooth cleanups never happen on it. That's how you do it per destruction. So if you want it so that a destruction just does never set a cleanup delay, the parts it destroys don't get cleaned up, then you set it to 0. If you want to disable smooth cleanups entirely, you can set this to false. You can also set the default smooth cleanup delay to 0 if you want to manually have to set a cleanup delay for cleanups to happen, All right. So, no cleanups will happen on this part, and also something good to keep in mind. If you destroy a bunch of parts and with a cleanup delay of 0, in the future you are able to destroy the same part with a cleanup delay of higher values, and it will then clean up those parts like normal. So you're not just forbidden from cleaning up these parts anymore if you do this. Okay. So up here, I have another heartbeat connection, and this one is a frequency loop going at 10 hertz. And actually, no, not 10 hertz. That was a little stupid. 10 seconds. 10-second loop. Okay. And up here, we're just going to call the Shatterbox.reset function. And it has 2 parameters, but really just 1. You're not supposed to use replicated. Replicated is true if the server is telling the client to perform a reset. So don't use replicated, like never. And do not revert ownership. This is in reference to the map parts. So I'm just going to leave this blank for now. And what we'll see happens is the map reverts itself. And actually, I'm going to make this have a cleanup delay of 2 seconds very quickly, just so that I can show you what I'm talking about. And I forgot to change the scene. Okay, there we go. What was that? Okay. Okay, so we saw the parts got moved to the camera, and they're there, and after 10 seconds, the ownership of these parts is going to get reverted. So these are going to go back to being where they originally were, and on the client side, the same thing is going to happen. See, client map just got reverted. I guess I switched at the exact time it happened, and you can see that the camera is now empty. Or I guess that's just a visual bug. Okay, so that's what happened. I want to show you that again because of that. Okay, so camera has stuff in it, and we're going to wait for these parts to vanish. This will be the ownership getting reverted. See, so they go back into being in the building. So that's how you would revert the map to being in the state it was before Shatterbox touched it, in the event that you want to like switch maps or something. Because if you were to do that without calling reset, there would be parts in the camera on the server side, and there would be parts in the client map folder on the client side, and it would just not go your way. So definitely call reset if you're going to be changing maps or something like that. Like putting a new map in the spot the old one was. Okay, so reset area is kind of obvious, isn't it? It's just resetting an area, and you can use the reset area function the same way you use the destruction function. It's only working with block parts for now. So you pass in a C frame into size, or you can pass in a part. I'm going to show you passing in a part. Make this thing nice and chunky. like that. Okay, and how it's going to work is you can see the parts that are in this area right now. Any part that touches this area right now will be reverted by this area. So it doesn't matter if you like perform destruction so that none of these parts are in the area anymore. Any of the parts that are in the area right now will get reverted. And that goes for any debris they create as well. So if this creates some debris and it goes flying all the way over here, ResetArea right here will revert that debris. So I'm just gonna show you that then. We're just gonna call ResetArea. I guess before that, I'm gonna show you that doNotRevertOwnership. Well, actually, no, I don't even have to show you that. You saw how the ownership was getting reverted. All of the parts were getting moved back into their normal building. What happens when that occurs is the client has to delete all of their owned parts, and that can cause a FPS spike on the client side. If there are a lot of client-owned parts, calling Shatterbox.reset might cause them a FPS spike, which is why I suggested to use it only when you're changing maps or something. If you don't want to, oops, what did I just delete? Okay. If you don't want that to happen and you're not going to change maps or something, so it's not necessary that the hierarchy reverts to normal, passing it as true means that the hierarchy just won't get reverted. Feel like I'm tirading on about that for too much, but it's more performant to not revert the hierarchy, is what I'm trying to say, I guess. Okay, I didn't have to delete all of that, but we can use ResetArea. We're just going to call in, pass in the block part, not the spherical part. Okay, workspace.area. Okay, so every 10 seconds, we're going to reset the area. And now we will remove the cleanup delay, so that doesn't happen. And that was a whoopsie doodle. I forgot to anchor the area. I might want to make a can collide false as well. Okay. So I'm just gonna swoop in from left to right. And yeah. Oh, it's not, it's, oops. That was a mistake. Okay, well, I would like to know why it just crashed like that, but because usually it doesn't do that. I guess because this is trying to be divided down to a grid size of 1, so that is quite a large number of voxels. That is actually a lot of voxels. Okay, so I guess that's why it crashed. Right, I need to make this indestructible. That totally made me blue screen for a second. And that's always something you have to remember when you're using physical parts as areas and hitboxes, and it's something that I forget because I never use them as hitboxes. Right, so we're just going to wait for this area to reset, and what we should see happen is that the ones over here, yep, are reset, and the ones over here are not. Okay, so that's kind of pretty standard, and one thing to keep in mind, with the ResetArea function, the ownership is never going to get reverted. And I actually don't remember exactly why I made it this way, but it is this way. The hierarchy just does not get reverted when you're using ResetArea. So if you want the hierarchy to get reverted, then you have to use the reset function. All right. I'm going to move on to the next function now. At this point, there are only 5 functions left to explain. 4 of them are only used when you're performing voxel destruction, like inside of an effect or after you've created the voxels using Imaginary. The last one is Shatterbox.Voxelize, which currently isn't compatible with the rest of the library, but I can either change it to make it compatible or just remove the function entirely. It takes in a part and a grid size, and it completely voxelizes that part down to its constituent voxels. So the part you pass into the function will end up getting destroyed, and it returns an array of voxels. that you can do whatever with. But like I said, right now it's not compatible with the rest of the library. I'll either change it or remove it. If you don't pass in a grid size, it'll use the default grid size. Okay, moving on to the final 4 functions. Starting off with Puppeteer. What is Puppeteer? Puppeteer is interpolated voxels. So this function can only be called in a server-sided effect, or, on the server side. So let's register an onVoxel destruct effect and call it test. All right. And all of this is going to do is if info.isAlreadyDebris, then return end. So if the voxel is already debris, then we're not going to do anything. Otherwise, we are going to call Shatterbox.Puppeteer. And why are we calling Shatterbox.Puppeteer? Well, we're trying to interpolate the voxel, and I'm trying to show you what it does. And why are we checking for isAlreadyDebris? Because we don't want to call Puppeteer on something that's already a puppet. I will probably end up adding a check to the module itself so that you don't have to do this, but it's good practice to do this anyway because it's more performant. I won't have to loop through the array to find if it's already in there, We can just see what this does. And on the server side, the debris is just going to look like normal, but on the client side, the voxels will be interpolated. So I'm just going to use slightly different syntax, create a hitbox, give it like a size of 10 like before, and then, yeah, I guess I'm just going to weld it to the player like before too. Oh, whoops. I should actually just do like this. Just to make things nice and easy. Don't have to make any connections or anything. We're just going to start the hitbox around the player when they spawn in. And we're going to use the onVoxel destruct of test. Okay, so this should work. So I can show you the interpolated voxels. Maybe we want to actually give these things some velocity. So I'm going to do that. Voxel.assembly linear velocity equals vector3.new math.random. Okay. Normalize that and then multiply it by 100. Or maybe just 50. Okay, so we give it some velocity. If it's debris, we return, otherwise we puppeteer. And I guess I'll just show you what this looks like. F5. Okay, so you can see it looks like everything is normal, but these are actually not physics items. On the client side, these are always going to be anchored debris, and they're indestructible. So the client can't destroy these. And we can just keep on walking into things to see all of the interpolated debris. Right, they're always going in that positive direction because I only chose positive values for the vectors. But yeah, you can see how that works, and I'm going to switch to the server side and drag my player around so you can see that on the server side it does the same thing. This is the problem I was running into earlier. Okay, so I'm just going to drag the player around and try and use the player like a hitbox. Am I even allowed to do that? Or is because oh, I can do that. Okay, so using the client as a hitbox, on the server side, all of these are physics objects until they slow down. See, so when it slows down and it stops moving, after a certain delay, all of these parts become anchored. So they're not going to move anymore if they're anchored. So we do have to add something to our destruction effect if we want pre-existing anchored debris to also get thrown around, and that is to just simply unanchor the voxel. I may add another function in the future which checks if a voxel is already a puppet so that you don't have to just unanchor all of the existing debris and you can just selectively unanchor the puppet debris. that would be a good thing to do. But for now, I'm just gonna unanchor all of the debris. Okay, so we can see these get flown around, and I'm waiting a couple seconds just to make sure they're all thoroughly anchored and sleeping. And I'll walk back over there, and you can see they start flying around again. And you can do this as many times as you want. The library will auto-anchor the puppets every time you unanchor them. So you're just free to unanchor them and throw them around, and they will sleep on their own. All right, so that's that for the Puppeteer function. And one thing to keep in mind is this puppeteering interpolation is pretty much one-for-one to the Jujutsu Shenanigans one. So what I mean by that is I'm going to just make this hitbox absolutely giga. And we're just going to overload the crap out of the system. And you can see how all of those debris started interpolating slower. That's because there is a limit. If there are more than 70 puppets that are active and moving, and that is the key, active and moving, then the debris gets slowed down. So you can see, let me just create bunches of debris, and you see how they start to slow down. And you saw how my game just lagged just then. That is only going to happen in Studio, because when you're in Studio, the server has to perform physics calculations, and it has to do this tweening. But when you're in the Roblox player, the client won't have to perform any physics calculations, just these tweens. So the physics, or the FPS on the client side, in-game, is going to be pristine with the puppet system. And you can see all of the debris start to slow down, and I'm just going to wait for things to come to a rest. Maybe I shouldn't have made so many debris if I wanted to wait for things to come to a rest, but, oh geez. Just making things worse. Okay, well, it looks like they're all resting now, so what I wanted to show you is the debris over here is still going to be nice and quick, see? So, really, the speed of the interpolation and the physics is entirely dependent on how many voxels are active and moving. Alright, moving on. I'm going to show you the GetOriginalPart function. I actually don't... what is a good test I can do to show the GetOriginalPart function? I guess I can change the color of the voxel depending on whether the normal is pointing up or not, to simulate, like, checking if a voxel is supposed to be a floor voxel. Okay, so moving on from Puppeteer, we're not going to be unanchoring our voxels anymore, but we are going to be doing nothing to existing debris. And what are we going to do? We're going to simply get the original part. And how do we do that? We use info.dirtyGroupID. Okay, so now I'm going to explain what I mean by original part and also what a dirty group is. Okay, so when these parts are the originals, right? When Shatterbox destroys an original, quote unquote, it doesn't actually destroy it, calling destroy. It just sets the parent to nil. So all of these parts are still going to be in existence. And when the reset function is called and ownership gets reverted, they're just, put back into the original spot they were. No instance creations have to happen. So that is what the original part refers to. It refers to these parts that were never destroyed. So they're going to have their original C-frame, size, and all of their materials and tags and whatnot. They're not going to get destroyed. Okay, and what is a dirty group? A dirty group is a group of voxels and static parts that spawned from one part. So the spawn location. Before, it was getting broken up into debris, but it wasn't entirely getting broken up into debris. Sometimes there were static parts and sometimes there was debris. Both the debris and the static parts are part of one dirty group because they're all spawned from this one part. And the same thing goes with all of them. So each part corresponds to one dirty group or not any dirty groups, in which case that part is an original part. Okay, so now we have the original part and you know what a dirty group is. We're just going to raycast to the original part and see what the normal is. So we need raycast params. We need params filter type equals enum.raycast filter type include, and we filtered descendants. And what are we going to filter to? We're going to filter original. I'm going to, before the raycast, stick the original back into the workspace. And then after the raycast, I'm going to take it back out of the workspace, like that. So now we can get our raycast result. And where are we starting from? Why don't we just start from the center of the destruction? That makes the most sense. Okay, so I think I explained all of the info parameters earlier. Cutting part is the cutting part as it was when the function was called. So this is going to be the true center of the destruction. Or I guess if you're using a sphere, it's the true center, not like a wedge. Okay, so the direction that we're going in, we are going from the center to the voxel. So maybe we actually separate out the origin, and I'm going to call it O. So that's the origin. We're starting from the origin, and we're going in the direction of the voxel. So when you want to get the direction, you just use subtraction. So voxel.position minus O. This is the vector that points from the origin to the voxel's position, and it's also that same exact length. So this is exactly what we need. This is a raycast that starts at the center of the destruction, and it goes exactly to the voxel, and it stops. It doesn't go any farther than that if it, I guess, somehow were to miss. And now we pass in the parameters. So we only check for the original part to see what the information is, right? And now from the logic that we've been going through, this raycast should never fail, because any debris that is, it's already debris. We're not doing anything. And down here, we're raycasting directly to the voxel's position, starting from the center of the destruction. So logically, this raycast should never fail. But somehow, it still can, so in some cases. I don't know exactly why, but you still have to check for if res, or if not res, then do something else. So we're just going to return if there isn't a raycast result. And that means we'll be just seeing a voxel that hasn't had its color changed if the raycast fails. And that's just what I'm going to do. I'm just going to have the voxels change color depending on if they're floor or not. Okay, so if we don't have a raycast result, then we're going to return end. We're going to get the normal of the result. Okay. Actually, we're just going to directly calculate if it's facing up. Is floor is equal to res.normal fuzzy equals vector3.y-axis, and we'll use some small number like this. So if the normal is roughly facing up, then it's a floor. Otherwise, it's a wall. And if you don't know what a raycast normal is, this is just the, yeah, I guess that description isn't too helpful, but what a normal is if you shoot a ray going any direction into a part, like the side it hits, the normal points 90 degrees from that surface. So pretty much what we're doing is we're raycasting towards the voxel, and if the normal of the surface, which is 90 degrees from the surface, if that points up, then it's a floor. All right, so we have isFloor, and we're just going to change the color of the part now. Voxel.color equals isFloor, and color3.new Man, that autocomplete just did not work for me just then. We're gonna make that red. So if it's a floor voxel, we're gonna make it actually green. And if it's not a floor voxel, we're gonna make it red. Okay, so it's green if it's a floor, and it's red if it's not a floor. Let's see how that works. All right, so that, let me, okay, well, actually, I guess it doesn't matter that much. So you can see, now that we're at the, I actually think that should be, no, because it's ray casting directly to its position, so it's hitting the side. But if I were to like jump and then go over it, you can see that those would be floor voxels. It's kind of hard to show you a floor voxel because of how big um, our hitbox is. So I'm gonna make it 10 again. Okay, so we've got our floor voxels, and we can do wall voxels. And you can see once we start getting closer, the raycast starts actually hitting the top instead of hitting the side. And yeah, so this is the method that Jujutsu Shenanigans uses to check if it's a wall or if it's a floor. And that's why sometimes if you're standing on top of things that should be considered walls, they will be considered floors. Yeah, I think I'll move on from GetOriginalPart now because that was a little convoluted. I spent most of the time raycasting and not getting the original part, but I think it was good to show you how to make an effect like that. So now we're going to move on to voxel count vector and voxel distance vector. Okay, so what do these two functions do? It's a little complicated to explain, but I have provided a description. Voxel count vector. It returns a vector that tells you how many voxels a box determined by size has on each axis as a fractional quantity. So you pass in a voxel, and you pass in the size of a box, and it returns you a vector 3 that tells you how many voxels that box has on each axis. And this can be a fraction. Okay, so if you wanted the legitimate number of voxels, you would just floor this number using floor like that. Okay, so I guess what I'm going to do is I'm going to show you a very simple effect where there's going to be a gradient in the center of the destruction, and it just fades out, and at the edge of the destruction it will be its original color. So we're going to do the same thing as before. Is if is already debris, we're going to return do nothing. Okay, so now we want to we're going to assume a spherical hitbox so that we can just use a magnitude check. That would be really easy. So we want to figure out, I'm actually going to explain both of these at the same time now because we need to use both of them, but voxel count vector. What we're going to want to do is get the number of voxels, the voxel distance, instead of the actual distance. And why would we want to use voxel distance? Because not every part is going to have the same grid size. It is true if you're using hitbox.GridSize that all of them are going to have the same grid size, but like I said before, that's not the preferred method to use. So if you're, for example, if you've got a building like me, some are grid size 4, others are grid size 2, the effect is going to look different per voxel if you just use raw distance. So in these cases, it will be helpful for you to work in voxel space instead of, normal distance space. And that is what these functions provide you. It provides voxel space coordinates from real coordinates. Okay, so we're going to call this max voxel distance. And since we're assuming a spherical part, the maximum voxel distance is just going to be the radius of the part, right? Because going from the center of a sphere to the edge of the sphere is just the radius. But the size of a part is going from end to end. So we have to take the info.cuttingPart.size and we have to multiply it by 0.5. So this is the radius of the part, But we want to convert this radius into voxel space because we want to know how many voxels long the radius is, I guess. Yeah, right. So we do that with the voxel count vector. Shatterbox.voxel count vector, and you pass in the voxel first, and then the size you're trying to convert now. Okay, so this voxel count vector is going to be a vector x, y, and z that tells us how many voxels away the edge of the circle is on each axis. And usually when you're working with a sphere, the size of a sphere is going to be the same on every axis. But when you're working in voxel space, voxels can have weird sizes. Like if I zoom in and go inside of this building, you can see, I guess it's actually not super easy to see, but the walls the walls and the floors of this building are not cubic. So the grid size is 4, but the walls are only 2 thin. So this way, the voxels are going to be longer than that way. They're not going to be perfectly square or cubic voxels. And that's why in voxel space, the radius of a sphere is not going to be the same on every axis. Like in our case, going from that short axis is, yeah, on the short axis of the part that I was just explaining. This way, it would be twice as long as this way, because there would simply be twice as many voxels going this way as this way. Okay. It's a little convoluted to explain this, but after you start working in voxel space, everything starts to make more sense. You're just thinking in terms of voxel rather than in terms of standard coordinates. So this is the maximum distance a voxel can be at on any given axis. So now all we need to figure out is what the actual voxel distance is. So what is the actual voxel distance of this voxel? And that is going to be achieved using the voxel distance vector. So we pass in the voxel as the first parameter. And what are we trying to get the distance to? We're trying to get the distance to the center of the cutting part, right? info.cuttingPart.cFrame.position. And I'll just explain what voxel distance vector is using its description really fast. It takes a point and it converts it to the voxel space distance relative to voxel. This is a vector which tells you how many voxels away the point is on each local axis as fractional quantities. It's possible for an axis to be less than 1, but never negative. And I guess I should also say, for the voxel count vector, it is not possible for there to be an axis less than 1, because there is always at least one voxel on every axis. Okay, so we're just trying to get the distance to the center of the cutting part in voxel coordinate space, and we do that, like I said, just pass in the position of the C-frame. And this is now a vector which tells us how many voxels away the center of the cutting part is on each axis. So now it would be nice if we could normalize this distance so that we can use like color 3 lerping. And now that we have a maximum voxel distance and a standard voxel distance, or our normal, or no, not normal, our actual voxel distance, we can just divide those two. Okay, so one thing to keep in mind here is that since we are using a spherical hitbox, this normalized distance will have a magnitude in the range of 0 to 1, because that's how spheres work. They have a consistent magnitude. Now, if it was a box, this would not be the proper way to normalize distance. You would have to use minimums instead of division like this. Okay, so now we're just going to get the magnitude of this vector, because like I said, the magnitude is going to be in the range 0 to 1, and that's exactly what we want for lerping. So for what I'm going to do is I'm going to do voxel.color is equal to color3.new, so black, we're going to lerp that to the original color of the voxel. And that is going to depend on the normalized distance. So normalized distance is a number from 0 to 1, but actually it's not going to be precisely 0 to 1. So we might as well clamp that. It is going to be 0 to 1, but it's actually going to be in that range because of just because voxels aren't going to line up perfectly with the hitbox. So we're going to clamp that in the range of 0 to 1, just to make sure we're not passing greater or less than 0, greater than 1 or less than 0 values into lerp. And now we should be good. In the center, the voxels are black, and around the edge, the voxels are their original color. So let's just make this red. So in the center, they're red, and around the edges, they're their original color. Okay, let's see how this works. Okay, so for a second there, it seemed like nothing was happening, but that's because we're creating server-sided voxels, and they take some time to replicate to clients. Like, destructions on the client side happen immediately so that the buildings don't flash, but now we have the problem that server-side created voxels flash, and that's fixed with the Puppeteer system. I don't think I'm getting close enough, fast enough to actually show you this. So let me make the hitbox faster. Or let me make the hitbox a lot larger and also a lot slower, which is managed with the destruct delay. I guess 5 seconds. And like that. Okay, so now you can see more easily that the gradient is working. Right? And it works across different spans of voxel size. Let me just jam myself up in here. Okay, and now to show that, oh, okay, my brain was kind of dying for a second there. I was like, why is it doing that? But all of these voxels should just be in here, and I can just select all of them. Okay, wow. It's like giving me brain damage. And I'm just going to set the transparency of all of these voxels to 0. Okay, and now we can see the pattern more easily. You can see that it went through walls and it's fading and bunches of nice stuff. I don't know. I feel like I'm spending too long explaining each things, but it is good to keep this in mind. Okay, those are starting to clean up. That's why that's like that. But yeah, I've showed you how to use voxel space to have consistent effects regardless of the size of voxels that are being destroyed. And I think that's every function that I want to cover in the library. So now this is pretty much what I wanted to show you. I just wanted to do a little extra thing in here. So maybe I can do that right now instead of at the end. If normalized distance is less than 0.33, then return end. We're going to destroy all of the voxels that are too close to the center, right? So voxel destroy. So this, since it's a normalized distance in the range of 0 to 1, checking for if it's less than 0.33 just means we are destroying the inner 33% of voxels. And now I'm going to write in a helper function. Okay, so this just maps one numeric range onto another. And what I mean by that will be kind of obvious in a second, but right now we have the color starting at red in the very center of the destruction where normalized distance is 0, and it fades to normal at the very end, where the normalized distance is 1. But what if we wanted to make it so that it starts at this, where we started destroying the voxels? What if we wanted to make it so that it starts here? It starts at 0.33, and then at 1, it is the normal color. That's what we would use mapping for. So what we're going to do is we're just going to map the normalized distance now, because we don't need it. And we're going to map it from its current range, which is, it's not going to be less than 0.33, So 0.33 is the lowest it'll be, and the highest it'll be is 1, right? Because it's a normalized distance. So the second part of the range is going to just be in the range 0 to 1, because that's what we want it to be. We want it to be from 0 to 1 for lerping. And now we can just do the same thing, clamping this, because map doesn't have built-in clamping. And we should be good to go. We can see, we should see that the inner 33% get destroyed, and all of the ones on the outside have a slow fade to their normal color from red. All right. So voxel destruction isn't so hard, right? Okay, so now I'm going to explain to you what each of the settings do, and that will be the end of the tutorial. Moving on. In this part of the tutorial, I'm going to go over all of the different hitbox parameters and when you would use them. So I'm just going to go through all of the different parameters in order, other than the ones that I've already gone over. So CleanupDelay is the smooth cleanup delay, if you've just skipped this part. OnVoxel Destruct is the voxel destruction effect that you want to use as a string, the name of it. GridSize, I really don't want you to use, but it does let you perform voxel destruction with any given grid size. And the reason why I don't want you to use it is because there are a few reasons. So if you perform destruction on a part such that all of the voxels no longer lie on the grid, greedy meshing just is straight up not going to work on them anymore. Which is a sad thing, but that is just how greedy meshing works. Greedy meshing relies on a grid having to exist. So if you go and destroy parts with multiple grid sizes, the grid might not line up anymore, especially if they're not multiples of each other, right? So that's why I don't want you to use grid size, but you can if you want. Skip encapsulated voxels. This is one that I'm going to show like immediately. I don't really know the best way to show it to you. I'm gonna copy this and then just use workspace.part for now and set the destruct delay to like 5 or 10, 5. Okay, and then we're gonna set the cleanup delay. I don't like how it doesn't give me autocomplete. There we go. I accidentally pulled up the emoji board. So we're gonna destroy every 5 seconds and clean up every 10 seconds. But I'm just trying to show you what the power of skip encapsulated voxels is, because explaining what it does directly is just going to be me sitting here explaining for 5 minutes again, and I feel like I've done that for way too much time in this tutorial. Gonna delete that part, that's just been there, ominously. Okay, and I'm just going to absolutely crank up the size of this thing. Crank it up, absolutely giga. And I'm gonna duplicate this and a couple times, like that. Okay, so skip encapsulated voxels. The easiest way to explain it is that it makes destructions an entire order of magnitude faster. It skips the voxels that are completely encapsulated by the hitbox, so any that lie entirely within the bounds of the hitbox are skipped and just not created. Well, because the hitbox is really small. It's kind of anticlimactic. Okay, so now we should see it. Okay, yeah. And you see parts that get phased out like that? It happens because they're too far away from the camera, and I guess my render distance is really small. Maybe, is it taking it from my client side? Can I like do it on the client like that? Oh, yep, it is taking it from my client side. Okay. So now that I have successfully made my graphics card kill itself, because I'm recording and doing max graphics at the same time, you can see that the destruction is happening pretty quickly. Even though we are easily subdividing like probably 100,000 voxels here, that's actually something that we can check. So in the hitbox, this is the next destruction parameter that I guess I'm going to show you. OnDestructCompleted is a function that passes in the voxel count, the amount of destroyed voxels, and it also passes in every single affected dirty group ID. And I will explain what a dirty group is later in the video, or maybe I'll just slap the explanation right here instead. I don't know. But this function just runs when the destruction is completely done. It's just removed from the queue and tossed aside, and then it calls this function. So voxel count. Let's just print the voxel count. All right, waiting for the destruction. Okay, so you can see that was 38,000 voxels. And you can see how fast that happens. There's barely even a stutter on my screen, even though we're deleting 38,000 voxels from the game. So how does this work? Do I explain that right now? I don't know. Pretty much, if a part is entirely within the hitbox, I don't even need to divide it. I don't need to perform the subdivision voxel destruction algorithm. You're skipping the encapsulated voxels anyway, so I'm just destroying the part. And I use a little bit of sneaky, clever math to actually get the total. So this is a nice thing to keep in mind. Even if you're using skip encapsulated voxels, the returned voxel count is still going to give you the proper number of voxels that were meant to be destroyed, even though those voxels never existed, or were never even calculated to have existed, because we just skipped them and deleted the part. And if it wasn't clear, what I mean by that is that this number is the same whether or not skip encapsulated voxels is true. Okay. Now I'm going to move on to next parameter. Maybe I will explain briefly why affected IDs is here. Affected IDs is here so that you can do something like this. Okay, so you've got, like, let's say you want to keep track of all of the materials that were destroyed. You can get the original part, and I'm going over all of these things in the tutorial. Maybe I'll just put this part after all of these things have been explained so that you're not just confused. So you use the dirty group ID to get the original part, and then you can get the material information from that original part. So materials, original part, material, I need to put type completing on that equals true. And then what we can do is we can do a similar loop. So we're just going to print all of the names of every destroyed material. And the reason why you would do this is, like, maybe you want sounds to happen when you destroy specific materials, but you don't want to put that into the voxel destruction effect, because then it would run for every single voxel, and that would be horrendous to your ears. So what this does is it loops through all of the affected dirty groups, and it keeps track of every single one of their materials in this array. And then for each unique material, it would play a sound or something. So I guess I can just show you that that does the thing. Concrete, smooth plastic, plastic, glass. All right. Seems like it's working fine. Okay. So the next parameter. What am I going to do next? Filter tagged. Filter tagged is either a string or it is an array of strings like this. And it is just a list of tags that you want to destroy. If it's not provided, it's just going to consider everything for voxel destruction, but let's say you wanted to only destroy map parts. If you had a tag called map parts, then it would only destroy parts tagged map parts like that. And like I said earlier in the tutorial, Shatterbox supports tag inheritance. So even though, or not even though, when Shatterbox moves one of these parts to the current camera, it inherits them, it will take this tag. So all of these parts in the building, even though they don't right now have the tag map parts, after Shatterbox moves them, they will. So that's good. The destruct delay is simply the amount of time in seconds between destructions when you are using Hitbox start. That is not a normal destruction parameter. It is only one of the Hitbox object. Okay. User data is a list of user supplied data that you can pass into your onVoxel destruct effect. So if I just go into one of the effects here, info also has user data. So user data is just a way for you to pass some stuff between the outside of the onVoxel destruct effect to the inside of it, right? So you do that just by setting values of user data, some stuff, and then it'll just get passed into the onVoxel destruct effect. Self-explanatory, it's just like using fastcast user data. I feel like that was above it before. They just changing the order around on me. Okay, so destruction type is also a setting of the hitbox and not a destruction parameter itself. It just determines whether or not you want to use the standard destroy function or imaginary, which doesn't have a frame limit and returns imaginary voxels. If you decide to use imaginary, then you have to use hitbox.imaginaryCallback, which is a function that takes in the voxels, or iVoxels, and the existing debris. And so when you're using hitbox start now, this imaginary callback will be used when imaginary destruction happens, and you can get the voxels in here and use them how you will. Okay. Weld connection event and start connection event are the events that the hitbox object listens to when it is welded or when it is started. So you can set these to whatever event you want, like run service.heartbeat or whatever, or if you're on the client side, you could do pre-render. That's a pretty good one for welding, at least. Yeah, that's what those events are. They just let you change the polling events of the hitbox. Exclude player's replication is used if you want to initiate a destruction from the client side and then replicate it to the server side, but you don't want to cause a duplicate destruction for that player. So let's say this player starts a destruction on their screen, and then you use a remote and the player tells the server that they did a destruction, and then the server should also probably do a destruction. This lets you exclude that player from the list of players that received the destruction. So this only works on the server side. They are changing these around on me. Okay, so the last two are velocity prediction and velocity bias. And these are also not destruction parameters, they are only parameters of the hitbox object. So velocity prediction, it only works if you have the hitbox welded to a part. And what it'll do is it'll use the assembly linear velocity of this part to predict where the part is going to be. And velocity bias is just a number which you can think of as how many frames ahead you want to predict. Okay? I think that's pretty self-explanatory. The hitbox will just try to predict the velocity of this part. So that's all of the settings gone over. I think I will now show you how to do a basic client-initiated destruction, and that will be it for this section. So to get a client-initiated destruction, I'm going to need a remote event at least. I'm going to need a something in the player. Give this requires handle false. Then a script, get a reference to that remote. Okay, and now tool script.parent.activated connect function like this our fire server. Okay, so this is the basic syntax we're going to use. What we're going to do is we're going to start the destruction on the client side using Shatterbox, and then we're going to use the remote to tell the server that it should also probably be doing a destruction. Okay, so we're going to get a reference to this event over here too, and then Shatterbox on the client side. Okay, and now why don't we just create our hitbox? Maybe we should make this just like same thing we've been doing. We can make it happen around the player, and maybe we get a reference to them here now. Okay. Okay, so we've got their humanoid root part, and what we're going to do on the client side is we're going to make a hitbox that just follows the client around, and it destroys around them every frame. So going to make a Shatterbox.create hitbox. We're going to make it the same size as the server hitbox, and we're going to do hitbox dot. Now we need to think about this. We can do the weld connection event, and let's get a reference to the run service. Okay, we can make the weld connection event pre-render. And what this will make it, what will happen now is that the hitbox will perfectly follow the character on their screen. So if you were to visualize this hitbox, it would follow the player with absolutely no delay. So this would be what you want if you've got like ragdolls and you want the hitbox to perfectly follow the character. And you can add some velocity prediction too. But that's what you would do. You'd set the weld connection event to pre-render, and we can do the start connection event. We can also set that to pre-render because we're built different like that. We don't care. Actually, I guess I got a little bit too ahead of myself there. I guess it was good that I did tell you about this just in case you were trying to use this for hitboxes on a ragdoll, but we don't actually need to do that in this case. We just set the C-frame in here. Humanoid root part.cframe. Okay, so we've got the hitbox. We've got the remote, and we should also probably pass in the humanoid root part C-frame to this remote, because on the server side, the humanoid root part isn't going to be in the same spot. So we should manually tell the server where we're at. And yeah, the reason I've done it like this and not so that you can just create a destruction on the client side and it automatically replicates is so that you can add your own server-sided sanity checks. I'm not going to show you how to do sanity checks. I will just show you how to initiate a destruction from the client, and this should be about what we need to do. About it. Hitbox destroy. Okay. So now everything looks like it's right, and on the server side, we've got the same size. We just connect to that event. r.onServerEvent connect function player C frame. And we set the hitboxes C frame to be the C frame, right? Yep, and then we also do the destruction on the server. But there is one more thing that we have to do. We have to set exclude player's replication, like I was saying before. Because this player is the one who started the destruction, we don't want to just send them the destruction again, which when you're performing destruction on the server side, the destruction automatically replicates to the clients. So we want to add them to the exclusion list. So this is the proper form for starting a destruction from the client. You just start it, you do the destruction on the client, you tell the server to do the same thing, and then the server does that. Or it doesn't. You can add checks to make sure exploiters don't just hack you to death. And let's see that. Let's see that happen. Maybe I should not have this here. I'm just gonna set can collide to false. Okay, so boom, we've got destructions appearing instantly on the client side, and if I go pop into the server-sided view, I really should just clear the map after I do each of the tutorial sections. You can see that down here, the server also has performed those destructions. Okay, all is well, everything is good. I think that's it for this section of the tutorial. Moving on. In this part of the tutorial, I'm going to go over each of the settings very briefly and explain to you what each of them does. So this is very clearly a toggle for the client-server algorithm. If you don't use it, you can't use client-sided effects from the server side because the remotes just won't fire. And it doesn't if you have client-server false, it doesn't change the hierarchy of the map, so you won't be seeing things put into workspace.currentCamera. Skip instance check. Oh, and it will also cause part flashing on buildings with streaming enabled set to true. So if you want to set this to false, you also have to set streaming enabled to false. Skip instance check. This one is pretty self-explanatory. You must return true if you want to skip this instance. So for example, if you've got a bunch of like cars in your game or something, you could maybe put some code in here to make sure this is not part of a car and return true to skip it, you know? Non-divisible interaction tells you, or it tells the library what to do to non-divisible parts. Destroy will just destroy them and they will become regenerated when a cleanup happens. Fall will make them fall down. And none just makes Shatterbox ignore non-divisible parts. I already explained these two settings. This is a toggle for the smooth cleanups, and this is a setting to set the default smooth cleanup delay if none is provided. Max divisions per frame limits the number of parts that can be divided by the destroy algorithm per frame. And for every one part that gets divided, up to 8 new parts get created. Greedy meshing does come to the rescue to try to save this, but this is just a general thing to keep in mind. Every frame, it could be possible that with 1,000 divisions per frame, 8,000 parts get created, in the absolute worst case. Earlier in the tutorial, you saw how the game crashed when I accidentally divided a part that was made of like 200,000 voxels. That's because my max divisions per frame is set to 1,000. If this was set to a much lower number, then that would not have happened. Okay, so this is the default grid size, self-explanatory. Max ops per frame. So in operation, I guess I'll start from the very beginning. Shatterbox destroy algorithm, the Shatterbox.destroy, it utilizes function queuing. So every time you call the function, the destruction data is inserted into a queue of processing destructions. This is because of the frame limit. if a destruction doesn't fully get completed, it has to go again. So even if it gets limited and it has to move on and another one has to take priority, it's just going to get inserted at the end of the queue. That's determined by this setting here. I feel like I'm going all over the place. It kind of sucks when all the settings are intermingled with each other. Well, anyway, max ops per frame just tells Shatterbox how many queue draws can be happened per frame. So 10 operations per frame. That's what this says. I should probably write a better explanation for it, but it does also limit the call to get parts and part, because for each operation, only one call happens every frame. Okay. The priority queue. If true, newer operations take precedence over old ones. If false, round-robin processing is used. So what this means is that instead of putting the operation at the end of the queue, if it's false, the operation just gets put at the end of the queue if it gets frame limited, right? But if it's set to true, if a newer operation gets frame limited, it's prioritized because it's newer. So the newer operations will finish before the older ones do, if this is set to true. And this setting is a hyper setting for this one. If priority queue is true, it prioritizes the recent n operations. So let's say there are 100 operations in the queue. The most recent 10 get prioritized using round robin. So instead of it going in order, like the newest operation finishes, the second newest operation finishes, the third one, it'll cycle between them. So you will find that these 10 operations just have slowed down rather than stopping completely until it gets to be their turn, right? I don't know. It's a little convoluted to explain. The default settings for these are pretty good. I wouldn't change these unless you really know what they do. Use greedy meshing. I am not going to explain to you what greedy meshing is, but I am going to throw some shade at Voxel Destruct 2.1. They do not use real greedy meshing. They use nearest neighbor merging. So they call get parts and part like 3 times for each expansion, and they just fuse those parts together, but that's not what greedy meshing is. Shatterbox uses true greedy meshing, which relies on the voxels being in a grid formation, which is what I call voxel space. Sorry. GM traversals per frame limits how many traversals through that grid can happen per frame for each worker. So 10,000 means that one worker can traverse 10,000 voxels worth of space in one frame. This limits the number of part creations per frame. It is a soft limit, not a hard limit, because there are certain circumstances where I am forced to create more parts than this, just so that there don't end up being holes in the ground for a second. And this is just the number of active threads that greedy meshing has. It's coroutine based, so this is the number of active coroutines can run. Each greedy meshing worker performs greedy meshing for just one single dirty group at a time. So with this set to 5, only 5 dirty groups can be processed with greedy meshing every frame. Okay, the Puppet voxel settings. Puppet max count determines the maximum limit of voxels. When this number is reached, the oldest voxels start to get phased out and replaced with new ones. And the hard cap is this number that it's currently set to. It can't go any higher than that because of the way I'm using buffers. The sleep velocity is how slow a puppet has to be moving to not get replicated, and this also determines when the timeout starts. And something else to keep in mind, I guess I should have explained this when I was talking about the puppets, but if a puppet starts moving slow and then it starts moving fast again, this timeout just resets. Okay. So the puppet has to be moving slower than the sleep velocity for this timeout to begin. And after it's been moving slower than the sleep velocity for longer than the timeout, that's when it becomes anchored. The replication frequency is how many times per frame a state update happens. So this kind of directly determines the number of kilobytes per second the puppets are going to use at maximum, like when there's more than 70 moving at all times. And this is because this is a frequency in hertz. You can think of it as like a frame rate of the puppets before they are interpolated. So if you set this to false, you could see the actual replication frequency on the client side. And the reason why it pretty much determines the amount of network usage is because I'm utilizing the full buffer. So that's 1000 kilobytes, or near. I'm actually only using around 982. But that means for every one that you increase, that can be considered 1000 kilobytes. So you can, the default settings are for 20 kilobytes per second network usage at maximum, and that's going to show up as receive on the client side. Client tween puppets is just a boolean which determines whether or not the clients interpolate between the puppets. And I've been calling it tweening throughout this entire tutorial, but I don't use tweening, I'm using lerping, because I feel like it's faster than having to create and destroy tweens and manage them. Okay, and then this is the distance limit. Outside of this distance, voxels aren't interpolated, even if this setting is true. Now that's all of the settings. I think I'm finally done with this tutorial. If you have any questions, leave them in the comments below. And, yeah. If you really need me to respond immediately, you can join the Discord. I think I will also leave that in the description above the timestamps. And, yeah. For future videos, I might show you how to make more effects with on voxel destruct effect, but maybe not. Thanks for watching.